another example of amortized analysis. Uh, Suppose this is the memory allocation problem. The name of the problem is the memory allocation problem. Memory allocation problem means what? Here we would like to store n elements in an array, and suppose the array size is limited. Means array size is limited means we cannot. So initially, suppose initially an array has been given. The name of the array is capital A0, and it has only one element. It has only one element, say 2. Okay. So I cannot store more than one element. So if I need to store more than one element, what can I do? In this case, the strategy is that double the strategy. This is the strategy: double the array size, copy the previous elements, copy the elements of the array, elements of old, copy the elements of the array. Okay. You can think like this: array into the new array. Although we are not creating any new array, suppose we are, I mean, you may think that these are the difference. Okay, means suppose this is a new array A1. Actually, I have doubled the array size, and I am storing it here. Means 2 will be copied to here. Okay, and so this is say A0, and this is the A1, and here you can store some new element 5. Now next, I cannot store more than 2 elements. So what I will do, again same strategy: you double the array size, copy the previous elements, and you can store. So you copy the previous element. These are the previous elements, so this is A0, A1, and this is the A2, A3. I am taking this array name as the A2, and here you see I can store another 2 elements, say 7 and 95, suppose. So in this way we store. Means once the array size is full, then we can allocate new elements into the array by doubling the array size and copying the previous element into the first half of the array size, new array. Means and then store the other elements into the rest of the portions. That means again you can do like this. Say see 1 2 3 4 5 6 7 8. So here this is the A3, and these elements are suppose 2 5 7 95, then 11 20 18 6, and these are the elements. In this way, this is the A2, A3, A4, so A7. Now you carry on like this. What happens? Finally, you will get an array of size n, where you will store the elements like this. Say, these will be the elements, and this is AK, where the elements are this A0, A1, A2, up to AN minus 1. Total number of elements, array element is N, and here the elements are this 2 5 7 95. You copy all the elements and you can store. Now, what will be the time complexity? Means you are doubling the array size, you are copying the previous element into this, and you are storing new elements. What will be the total array size? Now, here you see what happens in this case. Array size is 1. Array size is 2 to the power 0 is 1. Here you check it. In this case, array size is 2 to the power 1 is 2. So this one you see, this one will help you to find out the array size. So similarly here, array size will be 2 to the power 2 is 4. Here 2 to the power 3 is 8. So what value should be the k so that it will be n? So in this case 2 to the power k should be n. Okay, so that means k is log n. Here array size is 2 to the power k. Now, how much time it will take to complete all these operations together? You can think what you are doing. You are copying the previous elements here, 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 and then accessing the new elements here. I mean, storing the new elements here in these cells. So, how much time does it need? You see, how much time does it need from to get all the elements in a from ak minus 1 to ak? Just is it has ak minus 1 previous size, ak minus 1 previous array. So you see, to generate, that means because to generate from ak minus 1 to generate ak, I can write like this. To generate ak from ak minus 1, it needs how much time? B go of n. You see, this is the array ak minus 1 and this is the ak. So it has size like this and it has size like this, double of this. Fine. Now ak has how many elements? N elements. Its array size is n, I know, and its size will be automatically, here n by 2 elements are there, here n elements are there. So what you are doing, you are copying all this to here, you are accessing all this. Fine. And you are storing new elements here. So how much, what will be the time complexity? The time complexity will be, you are accessing all these n by 2 cells and as well as these n cells, so total number of cells is n. So here it will take n. So from ak minus 1 to ak, it needs we go of n time. Okay, linear time. So now how many total labels are there? I can say the array labels, I can say like this: array labels are a0, a1, a2, dot up to a k. So what you are doing, you are copying the array from the previous label to the new label and storing. Now in one level from ak minus 1 to ak, it needs linear time. And how many levels are there? Total k plus 1 levels are there, but you see, actually what you are doing, you are copying from a0 to a1, a1 to a2, a2 to this, dot up to ak minus 1 to ak. Okay, so how many times you are doing this? K times. So therefore total time complexity appears to be, I am writing appears to be a appears to be b go of n into k. That is b go of n to log n, because k is log n. Okay. But this is the worst case analysis. Please remember, this is the worst case analysis. So question is that what will be the amortized analysis? Amortized analysis. You see why I am saying this is the worst case analysis, not amortized analysis. You should take care of this, that I am shifting k means n by 2 elements here. Fine. But you see, how many elements are you shifting in the first level? Only one element. How many elements are you shifting in the second level? Two elements. So you see these two, one or four, these are constant. These are constant with respect to n. But you are assuming that at each level needs linear amount of time. Fine. At the last levels or just before the last level or 3 4 steps level, it needs linear. Fine. But you see there are so many levels where you need constant amount of time. So that means whatever you are doing is not correct. You are overestimating. So the total time complexity should be much less than this. So what should be the actual time complexity? Or I can say, if I average out all such operation, what can be the total time amortized time complexity of this procedure? Okay. So here you see, if I would like to compute the amortized time complexity, you see what the uh, method is doing, means what we are doing here, we are just copying the elements from array cell and you are putting it in the next array levels. Fine. And this, then again I am accessing 2, this 2, and I am copying these 2 from a1 to a2, 5, I am copying 5 from a1 to a2, clear, array a2 array, and then I am storing new 2 elements 795 as shown in the figure. Okay. Now if it is so, then I can see that the total time complexity will be just the sum of all the cells, because I am accessing each, you see, these one ones, okay, these cells, I am accessing these cells, I am accessing these cells to copy and store. Fine. So what will be the total time complexity? Total time complexity is nothing but the addition of the total number of cells of all these array levels. That is the time complexity. So now the question is how many cells are there, means total cells. So total number of cells are equal to, you see, summation of 2 to the power j I can write, where j varies from 0 to k, because in the first level you see 2 to the, it contains how many elements, 2 to the power 0, then 2 to the power 1, then 2 to the power 2, 2 to the 2 means 4 elements, then 8, 2 to the power 3. So in the last level 2 to the power k. So I am adding all this. So or you can write here also, if you have problem, that 2 to the power okay, I am writing this, and 2 to the, this actually 2 to the power 0, or just you write 1 plus 2 square plus 2 to the power k. Fine. Now you know this is the GP series, a into r to the power n minus 1 by r. So a is 1, r is 2, to the how many terms are there, k plus 1 terms are there, 2 to the power k plus 1 minus 1 by 2 minus 1. So this is 2 to the power k plus 1 minus 1. That I can write 2 to the power k into 2 minus 1. Now 2 to the power k is n, you know already that the last level contains 2 to the power k elements, and which is equal to n. So 2 to the power k is n. So if you put that, that will be 2n minus 1. So these many cells are there. So the amortized time complexity will be this theta open tight. So this, I think it is clear. So now I am stop here.